This is section 3.1 on inverse functions. In objective 1, we'll identify one-to-one functions. First, we will review. Suppose a relation consists of ordered pairs xy, where x represents a domain element and y represents a range element. Then the relation is a function, that is, the quantity y is a function of the quantity x, if each domain element corresponds to exactly one range element. Or, another way to put it, y is a function of x if each x value corresponds to exactly one y value. If y is a function of x, then its graph in the xy plane passes the vertical line test. Some new information from section 3.1. We're at this point right here now. A function is a one-to-one function if each range element corresponds to exactly one domain element. If y is a one-to-one function of x, then each y value corresponds to exactly one x value. If y is a one-to-one function of x, then its graph in the xy plane passes both the vertical line test and the horizontal line test. It passes the vertical line test because y is a function of x, and if it's a one-to-one function of x, then it also passes the horizontal line test. Okay, if we're given a relation of ordered pairs, xy, the inverse of the relation is found by interchanging the x and y coordinates. Here's an example of a relation that consists of just three ordered pairs, -2, 1, 0, 4, and 2, 7. We can verify that this is a function because each of the domain elements corresponds to only one range element. So that is, -2 appears only once as a domain value. 0 appears only once, and so does 2. So it is a function. We can check to see if it's a one-to-one function also, and it is a one-to-one function because each of the range elements appears only once as a range element. The inverse will also be a one-to-one function as a result, as you'll see. E inverse is found by interchanging the x and y coordinates. So for E inverse, we have the ordered pairs 1, -2, 4, 0, and 7, 2. Each of those is found simply by interchanging the x and y coordinates in the relation E. In the next part, we have four relations. The directions say find the inverse relations of the relations below, and then classify the relations and their inverse relations. By classify, it simply means to determine if each of the relations is a function or not, and if it is a function, determine if it is a one-to-one function. We'll do that not only for the relations A, B, C, and D, but also for their inverses. But first, we will find the A inverse. The A inverse, we'll just interchange each of the x and y coordinates from the x and y coordinates in A, so we get the ordered pair 0, 1, 3, 2, 4, 3, and 0, 2. That's A inverse. B inverse, interchange the x and y coordinates. We get 1, 1, 3, 2, 5, 3, and 7, 4. For C inverse, interchange the x and y coordinates. We get 2, 1, 4, 2, 7, 3, and 4, 4. And for D inverse, interchange the x and y coordinates. We get 3, 1, 2, 2, 1, 1, and 0, 3. Now we will go through and classify each of the relations and their inverses. Relation A is not a function because the domain value 2 corresponds to two different range values. 2 corresponds to 3 and 0. So this is not a function. Not a function. In relation B, the domain values 1, 2, 3, and 4, they each appear only once. So that means this is a function because each domain element corresponds to only one range element. Then we'll check to see if it's a one-to-one function. The range elements 1, 3, 5, and 7, they each occur only once. So this is a one-to-one function because each range element corresponds to only one domain element. So this is a one-to-one function. And then relation C, the domain elements 1, 2, 3, and 4, they each occur only once, so this is a function. When we look at the range elements, however, we see that the range element 4 corresponds to two different domain elements. So this is a function, but it's not a one-to-one function. So I'll just label it as function. And then relation D, the domain elements 1, 2, 1, and 3. The domain element 1 appears more than once. The domain element 1 corresponds to two different range elements, so this is not a function. And now we'll classify the inverses. For A inverse, the domain elements 0, 3, 4, and 0. This is not a function because the domain element 0 corresponds to two different range elements, 1 and 2, so this is not a function. B inverse, the domain elements 1, 3, 5, and 7, they appear only once, so that is a function. Then check the range values 1, 2, 3, and 4. They also occur only once. So this is also a one-to-one function. However, we know that ahead of time because relation B is a one-to-one function, so we automatically will know that B inverse is also a one-to-one function. Okay, relation C inverse, we'll check the domain values 2, 4, 7, and 4. Okay, this is not a function because the domain element 4 corresponds to two different range elements. So this is not a function. I'll just put not for not a function. And then finally, D inverse. The range or the domain elements 3, 2, 1, and 0, they appear only once. So it is a function, and it's not a one-to-one function because the range element 1 corresponds to two different domain values. So it is a function, but not a one-to-one function. Okay, so as you can see in this example, a relation that's not a function could mean that its inverse is also not a function, but as you saw with relation D that's not a function, its inverse is a function. And an important thing to remember, though, is if a relation is a one-to-one function, then we automatically know that its inverse is also a function. Okay, that is reiterated by this statement down here at the bottom. Every function has an inverse relation, but only one-to-one functions have inverse relations that are also one-to-one functions. Okay, we have an analytic definition of a one-to-one function. Okay, the analytic definition of a one-to-one function, let f of x be a function. If f of a equals f of b implies that a equals b, then f of x is a one-to-one function. If there is an occurrence where f of a equals f of b, but a does not equal b, then f of x is not a one-to-one function. Okay, so I will show you how to find or how to determine analytically if a function is a one-to-one function or not. We'll start with f of x. I'm going to write that on a piece of other paper. F of x equals 3x plus 4. And then I'll go through the steps to show you that it is a one-to-one function. I'll show you analytically. So we begin by writing f of a equals f of b. Since f of x equals 3 times x plus 4, f of a is 3 times a plus 4. That's equal to f of b, which is 3 times b plus 4. If we subtract 4 from both sides, we get 3a equals 3b. And then divide both sides by 3, we get a equals b. Right? So we show that f of a equals f of b implies a equals b. So that means that f is a one-to-one function. Okay, the second function is g of x equals 2x plus 1 divided by x minus 3. So we will also show that the function g is a one-to-one function. So we'll start by writing g of a equals g of b. And since g of x is 2x plus 1 over x minus 3, g of a is 2a plus 1 over a minus 3. That's equal to g of b, which is 2b plus 1 over b minus 3. And then we'll use the cross products are equal property. If two fractions are equal, then so are their cross products. One cross product is 2a plus 1 times b minus 3. That's equal to the other cross product, which is 2b plus 1 times a minus 3. Then we'll do algebra and arithmetic on both sides. 2a plus 1 times b minus 3, we get 2ab minus 6a, and then plus b minus 3. On the right-hand side, 2b times a is also 2ab, and then minus 6b, and then plus a and minus 3. So in the next step, we'll do a couple of things at once. We'll add 3 to both sides so that those minus 3's are eliminated. We will also subtract 2ab from both sides, and then we'll be left with negative 6a plus b equals negative 6b plus a. Okay, so what we can do now is we can do a couple of things. We can subtract a from both sides and also subtract b from both sides. If we do that, we'll get negative 7a equals negative 7b. And then divide both sides by negative 7, we get a equals b. Okay, so that shows that g is also a one-to-one function. G is a one-to-one function. Okay, the third problem, k of x equals x squared plus 1. So show analytically whether this function is one-to-one or not. We know ahead of time that this graph, the graph of k of x equals x squared plus 1, fails the vertical line or the horizontal line test. I mean, it is a function. It passes the vertical line test, but fails the horizontal line test. So it's not a one-to-one function. But to show analytically, we can just do this. We can say that on one hand, k of 2 equals 2 squared plus 1, which is 5, while on the other hand, k of negative 2 is equal to the number negative 2 squared plus 1, which is also 5. K of 2 equals k of negative 2, but 2 does not equal negative 2. And if you remember, that's what shows that a function is not one-to-one. So k of x, or the function k, is not a one-to-one function.